Hi, my name is Brian Caffo, and this is the regression module in our Coursera data science track. And in this lecture, I'm going to go over some basic notation and background. And I'm going to try and minimize the amount of mathematics required for this class, but I won't skimp on the details. If you're interested in some of the math, that won't be the point of the class, but if you're interested in some of the math, I will cover it. But I should emphasize that neither calculus nor linear algebra will be required. The most you will need to be able to do is some basic algebra and summation notation, and that's about it. Let's just start with some basic notation that we always use. We often describe a bunch of data points as, say, x1 to xn, where x1, x2 refers to the ordered list of data points. So, for example, if our data set was 1, 2, 5, then x1 would be 1, x2 would be 2, x3 would be 5, and in this case, n would be 3. And of course, we often use a different letter other than x. We often use y. And so we usually use letters to represent random things like random variables, and we'll use sort of an uppercase X to represent a kind of conceptual value of the random variable. And we use like a lowercase x to represent a number that we would plug into. So it would be meaningful to write, for example, that way. We often use Greek letters for things we don't know. So mu is a mean that we want to estimate, and we'll estimate it with the data level quantity x bar. Okay. So the empirical mean we can just define as simply this guy right here, and that's just the average, the 1 over n summation I equal 1 to n. So this notation right here just means add up all of the elements, and of course then we divide it by n. Notice an interesting thing that we'll kind of use quite a bit is if we take our data and we subtract off the mean, then the resulting data points have mean 0. And this is, let's just work it out really quickly. The summation of these xi tilde is equal to the summation of xi minus x bar, right? Which is equal to summation xi minus summation x bar. But this guy doesn't depend on I, so this is just nx bar because we've added x bar n times. And this guy is just the average, but we haven't divided by n, so this is also nx bar, so that's equal to 0. Okay, so anyway, this is the process is called centering the random variables. The sample mean is, of course, a measure of central tendency of the data. It's an attempt to define the middle. And in the previous lecture, we said that, the mean, in fact, was the least squares solution for minimizing that equation right there. Okay.